How we doing today, guys? This is Mr. Novak. For today's lesson, I want you guys to learn about how to graph speed. So we've been learning about speed already, where we know speed is equal to distance divided by time. Now what we want to be able to do is to apply that to graphing. Okay, so let's take a look at this first problem here for how we're going to graph. All right, so if we take a look at this, this is speed and graphing practice, right? It says make a graph of the following data from a race car. Okay, so if we take a look here, we have times listed and we have distance listed. Okay, so if we take a look at our graph, we have time, which is going to be on the x-axis, just to kind of any refresher, right? This is always going to be the x-axis, and up here is going to be the y-axis. Okay, just a little kind of quick review of the different axes that are involved in graphing. So what we want to do, if we take a look here, time is going to be on our x-axis. So we have to figure out how we're going to label time on our x-axis, and our y-axis is going to be distance. So let's take a look here. So if we notice about our times here, right, they're all going up by 5, right? 0, 5, 10, 15, 20, you know, and so on and so forth. So if we take a look at this, what I want to do is to label off these times. So I'm going to use them by going up by 5. So I'm going to start off at 0. And then I'm going to do 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay? So what you want to do whenever you're graphing, you always want to look at your data and see what would best fit. So if I look at this, I notice that they're all going up by 5s. I should try to put my data in going up by 5s. Okay? So then let's take a look at our distance, right? So our distance, if I look at it, we see it's going up. Sometimes it's not going up all by the same amount, but I notice that it's 550 or kind of my range here. So what I'm going to do is I'm going to go up by 50s. All right, we'll see how that goes. So if I go 50, 100, 150, 200, 250, 300, 350, 400, 450, and 500. Okay, so we are now labeled, right? So now we have we have our x-axis done, we have our y-axis done, right? We have all the things. So if we take a look, we know 50 is our highest time, so we know that's going to be covered, and we know 500 is our highest distance, so that is going to be covered. So now what we want to do is to mark the points, right? So what we're doing here, what we're going to do is we're going to look at our time first, right? And then we're going to look at our distance. So if I look at my time, right, my time is 0, and my distance is also 0. So, right, so it's going to stay right there, okay? Then if I do my next one, my time is, and I'll just check it off as we go, right? My time is 5, and my distance is 50. So I'm going to go over to 5, and then I'm going up to 50 and marking my dot, okay? So my next one, right, 10 and 100. So I'm going to do 10 and 100, then I'll check that one off. Next one is 15 and 100. Check that one off. Then I do 20 and 150. Check that off. 25 and 200. Check that one off. 30 and 250. 35 and 250 again, 40 and 350, and 45 and 450, and our last one is 50 and 500. So I have all my points. So what I want to do is I want to make sure I label all of my points. So what I'm going to do is I'm going to go through and label all my points. Okay, so I have, this is point A, this is point B, C, D, E, F, G, H, I, J, and K. Okay, so now we are all good. We plotted our points. We labeled them with whatever letter it's supposed to be. Now for our next part, what I'm going to do is to connect the dots. Okay, so we can take a look at it. All right. We're connecting our dots. Nice and easy, okay? All right, so now that we have our points labeled, we have a line. What we want to do is to kind of look at our graph to kind of interpret it, to see what the graph is telling us, okay? So let's take a look. If I scroll down, our first question is saying name the points where the car is not moving, okay? So if we look at this, what we want to see is when a car is not moving, it's going to have the same distance. So the 2 points, if you take a look here, our 2 points, if you notice right here, from C to D, right, it stays at 100, right? So it's at 10 seconds, at 10 seconds it's at 100 meters, and at 15 seconds it's 100 meters. So that means the car didn't move. It's staying at 100, right? So it's staying at the same distance. So that's one thing that we could mark down where it's staying the same and where the car is not moving. And the other point, if we take a look at, is point G and H, right? So at 30 seconds, it's at 250 meters, and at 35 seconds is at 250 meters. So both of those are flat. So if you notice, right, it's making a horizontal line is a flat line. So if we see that, that means it didn't change, right? Our distance did not change, so it did not move, okay? So for our first one, we're going to put, there's 2 points, right? So from C to D, okay? And from G to H, okay? So those are the 2 points where it's not moving, okay? So our next one where it's saying between which points is the car moving the fastest, okay? So if we look at this, when we interpret this, whenever you look at a graph, you want to see if it's going up at a steeper line, it means it's going faster. So if we notice, right, between C and D, right, it's not steep at all, right? It's flat, so it's not moving. So what we want to look at is what part is the steepest line. So if we look at between A and C, it's pretty steep, right? C to D, it's flat, right? From D to kind of G, it goes up a little bit more. G to H is flat again, right? Because it's not moving. And then if we take a look from H to J, we see that the line is a lot steeper than the other ones, right? So if we look from this point, right, from here to here, okay, it's really steep. So that tells us that the car is moving at the fastest point from that point, from letter H to letter J, okay? So whenever you see something that is really steep, that's going to tell us what part is moving the fastest, okay? So if we take a look at this, our next one, okay, between which points is the car speeding up? So there's a couple, if we look at our graph again, there's a couple points where we see that the car is speeding up, right? Kind of in kind of our main two, right? If we look at from C to D, right, it's not moving, but we see it speeds up from D to G, right? So from here to here, right, from here to here, it's going up, okay? It's moving faster, right? It's speeding up. Then from here to here, it's stopping again, right? From G to H, it's stopping. But then we look at it from H to J, right? We talked about this before. It speeds up again, okay? And then from J to K, it kind of slows down a little bit. So what you want to do for our points that we see are speeding up, it's from points D to G, okay, and from points H to J, okay. So really, when we're looking at a graph, that's the most important thing of seeing where it goes a little bit faster, right, than before. So if we notice that it stopped, then it's obviously going to go faster if it starts to go at a steeper incline on your graph. So our next question is, what is the average speed for the entire distance traveled? Okay. So just a reminder, guys, when we're calculating this, okay, when we calculate speed, we know speed is equal to distance divided by time. Okay. So when it says the entire distance, that's talking about the whole trip. So if we take a look here, the whole trip took 500 meters, right? And it also took 50 seconds. So that's how long it is. So we're just finding the average. So we know our distance, okay? Our distance is 500 meters, okay? And our time is 50 seconds. We whip out our handy dandy calculator, right? We do 500 divided by 50, okay? And we're going to get equals 10 meters per second, okay? So really just kind of review of the math that we're doing. All we're doing is applying the math. That's all we're doing, okay? So we have 10 meters per second, okay? All right, and our last one here, okay? So we found the average speed for the whole trip. Now we want to find what the speed would be between 2 points, all right? So it's saying between point G and point J. So if we take a look here, right, point G, I'm going to circle that. Let me circle that with a different color. We'll do blue. All right, point G and point J. So we want to find out what those points are, right? So if I know this is, let's take a look. G is going a distance of 250. And it goes 30, right? This is for G. And then H is going, J, sorry, excuse me, is going 450. Here, let me erase that. 450. And it goes a distance of, let's see, 45, okay? So we have those times. So what we're going to do is I'm going to bring those down and we're going to subtract them to find our total distance and our total time. So if we look, right, so for point J, I'm going to label this point J, right, it traveled 450 meters and it in 45 seconds. Okay, we see that. And point G is going 250 meters in 30 seconds, okay? So what we want to do, okay, we want to find the difference between these 2 points. So what we're going to do is we want to calculate our speed, so we have to know what our distance and our time is. So what we're going to do is we're going to take we're going to subtract our distance from point J to point G. So if I do 450 minus 250, right, I'm going to get a total distance of 200 meters. So that's how far the car went between those 2 points. All right, and then we're going to subtract our time. So we have 45, right? 45 seconds minus 30 seconds. All right, so that's going to be 15 seconds. Okay, so we have this already. It's set up now. So we have S equals D divided by T, right? This is our distance, right? This is our time. So we'll we'll divide those numbers. So if we do 200 divided by 15, we're going to get 13.3 meters per second. Okay, so this is a very long problem. So if you have any questions on this, please ask me. And after this, you guys are going to be doing some more practice problems with this. So if you can solve this problem, you can solve any problem. Okay. If you have any questions, let me know. Okay. This is Mr. Novak signing off.